Dan, can we get a mic check?
We
please?
died. Everything's gone.
Reada, can we get a mic check, please?
This is not the worst show ever. It's going to be what we make of it. It's going to be the best show ever.
All right, we're going to do a run through.
Live from the Key TV studio to your TV and on the web, it's Homework Hotline. Go to homeworkhotline.tv to ask your math or science questions.
Hi, welcome to Homework Hotline. My name is Dan Schofield. I teach science at St. Bernard's Academy.
My name is Reada McConnaughy, and I teach math with Northern United-Humboldt Charter School. And you're watching Homework Hotline.
Yes, welcome to Homework Hotline. You can watch us on television, or you can tune into the live stream at homeworkhotline.tv. And from there, you can either click on the live stream, or you can click on the link to ask us questions. There's that email link, and you can ask us your math and science questions
Okay.
if you want.
You can
also call
497-5044. In the meantime, we'll do some math or some science experiments.
or math experiments.
You're funny.
Yeah, very fun. Actually, this has to do
I
with
love
math.
math. This is awesome.
This is Ohm's law. We know Ohm's law.
Ohm's law.
Yeah, volt V equals IR. We can do some math. We'll do some math.
Awesome. V
So
equals-
that was
What's
pretty
I?
cool. I is current. It's in amps.
Okay, and R is
Resistance in ohms, and V is voltage.
Cool.
Voltage in volts.
Cool.
Voltage equals IR.
Awesome. What other forms of, what are the labels?
When I remember that, it was like this. I could go V equals IR. So it's V. I saw it like this. V I
15 seconds.
times R.
Like that?
And then you can cover it up.
Okay.
It's like that, or if it's like this, you cover that. So R equals V.
Well, thanks for
divided by R.
joining in.
Bye.
Bye.
Here we go.
Live from the Key TV studio to your TV and on the web, it's Homework Hotline. Go to homeworkhotline.tv to ask your math or science questions.
Hi, welcome to Homework Hotline. My name is Dan Schofield, and I'm a teacher at St. Bernard's Academy.
And my name is Reada McConnaughy. I'm a math teacher with Northern United-Humboldt Charter School, and you're watching Homework Hotline. Thanks for joining in.
Yes, welcome to the show. We are here to answer your math and science questions. So if you have one, you can
go to homeworkhotline.tv. There's an email, and you can send your questions to that email.
You can click on the email link or click on the live stream link, watch us on YouTube, or you can call us, 497-5044, and we'll take your questions and see if we can help you out.
Math and science questions?
Math and science questions, right.
Okay.
In the meantime, I want to do a little bit of looking at some what's called a multimeter. Some fun stuff. Yeah, I was here last time and we never really got to this, playing around with current. We got to static charge a few weeks ago. We had the Van de Graaff generator, and we were having a lot of fun with static charge. But we want to look at what happens when you put charge and you have it go into a circuit, which is when a charge that's flowing from one place to another and back again, so around in a circuit. And one of the best devices to use for one of these things is something called a multimeter. And I wanted to play around with that and just to show you the various different parts of what we look at with current. And I'll start with one we don't look at as much, I think. People are interested in the voltage and they're interested in the current. But there's a big part of it as well called resistance. And I thought we'd start with just resistance. Everything has some electrical resistance, and that the resistance is how tough it is for a charge to flow through something. And I can show it this way if we want to look at it. So this is a setting. So if we look at our multimeter, there's a couple wires sticking in here, and then there's some dial. And so I can set the dial to a variety of different things. And the wires have to go in the right place. And so the black one always goes in this thing called the COM port. But the red one goes into a different port. And this works on pretty much most multimeters, depending on what I want to measure. The red one can go in to, I'm going to put the red one in this one because this is where it's going to measure resistance. And so I'll start with that. And let me take a...
How would you describe resistance?
Resistance is like how much resistance is how much impedance there is on the charge. It'd be like water flowing through something. There's going to be more resistance on it if it's a really narrow pipe would have more resistance.
Okay.
A really wide section for the water to flow would be like, if you think of the charge is like a river or water in a river, it'd be how constrained it is would be how much resistance it has.
So wider river, less resistance?
Yes, that's right.
Because there's more flow?
Yes, and it works exactly the same way. A bigger wire will have less resistance than a little tiny wire. In fact, the light bulb is actually a really, really microfilament that's twisted and turned, and that's why it has a lot more resistance in it, and it actually has so much resistance in it that it lights up when you put a current through it. So let's try this on. I have it set to ohms. Okay. And let's try it on the board here. So we're going to try this out and aim it at a camera and see if we can see it pretty well. And what I want to do with this is test some resistance of, let's see, let's aim that. Oops, the other way. There we go. It says OF right now because it doesn't have any kind of connection. There's no current going through it because it's in the air. But what I want to do is let's take a look at some like a beaker full of water. And I'm just going to start with some tap water in a beaker and see how much the resistance we have in some tap water. We can play around with this. And so let's I'll put it right, let's see, put this in front. Yeah, perfect. And then let's look at that, see if I can read it from there. And okay, so it says it's at, I'll hold it still. Let's see, 500 and...
Is there a decimal point there?
Oh my God. I've got to zoom in on it for a second. So let's look at the meter. So I can't see. Okay, there we go. And that says 5 like 1.74, and it's I believe it's mega ohms, right? Mega ohms. Yeah, there's a little m right there. That's quite a bit of resistance in regular water. But let's take a look at what happens if we put, this is tap water.
Should I write that down? That seemed like
About 1.6, I believe is what it said. I'm going to look at this one just to be double sure that we're getting the right numbers.
1.6, you said mega ohms?
Yes, mega ohms.
So is it like mu for M?
It's big capital back. Yeah, M, yes.
Okay.
1.6 million ohms.
Okay.
So let's take a look at what this one would be. And this is distilled water. And let's see what that's going to be like if I'll put it in here.
Why would distilled water be different?
Well, okay, so let's see if it is different.
Okay.
And then distilled water is made just by purifying water completely.
Okay.
So there we go. And then we have 2.2, looks like, yeah, 2.2, 2.3.
It keeps going up.
It'll settle down eventually.
Okay.
What's that now? See, it's slowing down to 2.5.
Okay.
So quite a bit more resistance in distilled water. And so charge does not flow. I mean, there's things in your tap water that there are particles, there's some ions in there that help charge flow through there. So the charge is not flowing through the tap water as much because it's just straight water. It'll flow through it some, but once you get things in your tap water, it'll flow easier.
So more resistance?
More resistance, yes.
Because less things flowing through
There's
distilled.
there's fewer ions in there, and charge will
Okay.
flow through it. And so what you can do is you can play around with this, and let's try something. Like, let's put a little bit of salt in my distilled water.
Okay.
And see what that does. And again,
Let's see if I can write distilled.
DIS.
No, it's not
DILLED,
quite working.
distilled. All right. So I've stirred a little bit of salt in my distilled water. And let's see what that does. Now I'm going to measure the resistance now. And let's take a look at the screen. Okay, there we go. Okay. So that says 240.
Kilo?
Yeah, do you see the K though?
Kiloohms?
It's kiloohms. So we went from 200, like what?
230 kiloohms. So kilo is less than mega.
Yes, it's 1,000 times less than mega. So it's so much less resistance in
Wow.
salt water. And so
So does that mean electricity can flow through it really well?
yes, there's not as much resistance.
Not much resistance.
I mean, it's not like having a wire, electricity flowing through a wire, but it's a lot less resistant than.
You know, we did Play-Doh one time, and it had, the salt, and
Yes.
then we plugged in electrical. I'm
They
sorry, I don't
left
know.
right, you left electrodes into it, and you
Yeah.
got the stuff that go through the salt. I mean,
Yeah, and they would make lights, make
you
things
can
light up
because
and
the
move.
current was able to flow through the Play-Doh. That'd be a fun thing to do in here.
So salt is a really good.
Yeah, salt is a really good conductor of electricity because it breaks down into sodium chloride. So which are two ions that will let it go through it quite easily. Would be interesting here, and I don't even know what's going to happen with this, but let's say we took a little bit of distilled water, and instead of mixing salt, we'll just having something that really is not ionic, it's just going to dissolve. Will sugar make it? Will sugar make it flow easier?
They
Again,
look about the same, right? Salt and sugar,
well, this is a
but
little bit of
different chemical makeups.
right. So it's a completely different chemical. Sugar molecules are huge compared to salt molecules, but
Your sugar looks very brown.
it is definitely it's the
Is it like the
brownish sugar.
coconut sugar?
It's that sugar in the raw, I think.
Pure sugar.
Right. And so let's try this.
Okay.
And
So you're thinking it's going to be
I think it will.
opposite of what salt did.
I think my hypothesis.
Okay.
I'm going to guess is distilled was 2.5. Salt is about 100 times
Less.
Less, am I right about when I say that? 10 would be, yeah, this would be, yeah, I would think it would be, between the two of those.
Okay, so
Yeah,
somewhere between
yeah.
the distilled and the salt water.
Yes.
Okay.
I think it maybe be, okay,
Plain
so,
old
okay, here we
distilled.
go.
And we're in the kiloohms.
But,
More than salt.
yeah, more than salt.
And it keeps
About
going up.
Yeah, no, I think it has to reach an equilibrium or, but it does keep climbing. Look at that. Slowing down.
So when it hits 500, no, it'll keep going. When it hits 999
You know what?
kiloohms,
You know what's
then
going
it'll
on?
jump over
It
to
depends. It is. I have to hold it still.
Okay.
It's me. It's my hands moving around a bit.
User error.
It is definitely user. Like watch. I'll watch. We can change. Like there is. It does make. Of course, if it's closer, there's less material there. There's
Right.
less resistance. So
Right.
it does seem to be. But it seems to be in between
Oh.
the two. Now we're up to
How did
some.
Three.
It's
three
mess. It's. I
megaohms.
pulled one out of the water. So. Okay.
Oops.
So I think we are in between the two.
Okay.
But not quite as much. But
Well,
definitely.
it was
definitely
like 3 megaohms, and that's
Right, it was when I pulled one out of the water. Yes, it did affect it. So, and of course, then we could say that like right now, it's at some crazy now. It's like it's off. There's completely resistant. There's no electric current going in the air right here between these two terminals.
Okay.
But if I touch it, there's absolutely no resistance at all. You can do things with this just to check the resistance of a battery to make sure that you don't have a broken circuit. You can check the resistance of a circuit. If I put it on a battery, and if I just I'm checking this with the ohm meter, it should say. Yeah, no, sorry, it should say something. It shouldn't say
it
that.
doesn't matter if it's wet. You're not going to get a shock.
The battery's not going to give me a shock.
Okay.
And it's good. Thank you for doing that. And
Just
I might
checking.
get a bad reading because of the sugar water. Is what I'm wondering.
Okay.
But I can go and look at this and see if my battery is.
So there's a plus end on a battery
Mm-hmm.
and a negative end. Are you putting the red on the plus end?
I put the red on the plus end, but it doesn't. It'll
It
just
won't
make
matter?
a negative read. I think I have a bad battery here.
Oh, well, that's a bummer. I had a bad battery in my mouse today.
I can check to see if there's current flowing. Okay, let me get the setting right.
All right.
All right. Okay. Let's show the other thing we can do with this. We can check current through like a regular wire, like how much not current, but how much resistance is there in the wire. And there shouldn't be very much resistance at all. So hopefully that's. Yeah, there's this line right here. It says like 0.3 or something like that. 0.1 ohms of resistance. So it's
Wow.
very little resistance in a wire. And that's why I mean if I just took this wire here, there's very little resistance. And this brings us to our to something called Ohm's law, which shows the relationship between voltage, resistance, and current. And so if I just took, and the way that works is that voltage is equal to current times resistance. And so how much current can you get? Well, I mean, if we can rearrange that, so it's voltage equals current, which we say is I, times resistance, which is R. I can rearrange this equation to say, well, how much current is going through that? It's going to depend upon how many volts I have and how much resistance I have. So if I rearrange it, I say, okay, current must be equal to.
This is current.
Yes, current is I, yes.
Okay.
And it must be equal to voltage divided by resistance, right? If we just rearrange that. And so if I have very little resistance like I have in this wire, practically nothing, what's going to happen to my current?
Well, if you're dividing by a really small number, then this is going to be about equal, right?
Well, I mean, it's like a really super small number. So my voltage, like if I put it up to this battery, which is 9 volts, well, what's 9 divided by nothing?
Undefined.
Undefined, right? Or if it's a really small number. So if I take this battery and I just hook it up with a wire with no resistance together, it's going to have this crazy, it's called a short circuit is what it is. It's a short circuit, and that's what happens in your house if something breaks and you have just a straight wire going between it. Or if I do this, and if I just hold these wires together, I'm going to make a short circuit. And what's going to happen is it's going to get hot really fast. So if you just hold the wire up to the battery, if I just hook these wires together like this, it's going to just go around really quickly. And so the current is really, really high because there's hardly any resistance there. 9 volts, 9 divided by a very small number is a really big resistance. I mean, it's a really big current. So there's lots of amps. So we measure current in amps, we measure voltage in volts, and we measure resistance in something called ohms. And ohms, yes, right, that you use that notation, that omega for the ohms. And we can measure all those things on this. And so, for example, I can say, well, is this battery any good? Is it still have, it says it has 9 volts on it, right? Well, I can check to see if the battery's not good with my multimeter. And so I'm going to keep the wires in the same place because it says that's how I measure voltage. And now I can switch it over to the volts, which is right here. And again, it should be right around 0 when I don't have it on anything. And then we'll point it over the thing. And then, so it should be about 0, and I'm going to hook it up. I'm just going to hold it here, so I'm going to lose a little bit from holding it. And again, it's just 9 volts, so I should be okay. And there it says 8.72 volts. And you see the little volt V next to there. 8.72. And so that means the battery's in pretty good shape.
Right, because at maximum it would be 9 volts.
We would, yeah. And then I can also see this little battery, this little double A battery. It's supposed to be 1.5 volts, each one of these. And let's see what that does. Oh, I'm looking at the screen. And it's at 1.3. Now if I switch the contacts, it'll show me positive numbers.
Okay.
1.36. It doesn't really matter. It's just by convention about which is positive, which is negative. 1.36. So this lost a little bit, but still has most of it. And if I put 2 of them together, 2 batteries together, one in the right direction on here, let's see what this does.
Should be about 3 something.
It's supposed to be 1.5, so if it's completely good, it should be 3. And it's 2.7.
Okay.
So 1.5 plus 1.5 is 3, and so it's 1.7. So it's pretty
this
good.
can be a battery tester, and then you can test how much is left in each battery.
That's right. And another thing we can do with this is, like if I take my 2 batteries together, we can play with circuits as well.
Okay.
Now these are from a old Christmas tree light strand, a Christmas light strand, and I disassembled it, and when it went bad, I just took these off, and the wires can be used. And what's nice is that these will light up with about 1.5 volts with just regular batteries. You can use these.
So you're going to use your 2 AA batteries.
I'm going to use my 2 AA batteries.
Okay.
And I can hold these together, and it should light up. And it does.
Yay.
And I can measure, well, how much resistance do I have going through this light? How much resistance does this light bulb provide in here? So I can solve some problems. We can do a little math for you.
Okay.
I know you like to do
I
math.
love math. Yes.
So the thing I haven't done yet is I haven't measured current. Yes, I measured some resistance. I measured some voltage. But let's see what happens if I measure current. I'm going to just use these alligator clips. They'll add a little bit of resistance on it, but it makes it easier for me to set this up. And so again, I'm going to make sure this is working. My little setup is working by hooking up my batteries.
So resistance is ohm. I'm just clarifying.
Yes, resistance is ohms.
And
Current is in amps.
Amps.
And voltage is in volts.
And then O-L-T.
Good.
That doesn't look quite right, but
That's great. Now, again, I can measure my voltage, and I'm going to do it actually with all the wires hooked up to see if I have it right.
oops.
And I'm going to measure how many volts I have with this, because I think I have it set to voltage. And it is 2.68 volts with the 2 batteries hooked together. 2.861 volts. All right. This is where, so it's 2.68, right? It's 2.68 volts. And when you use this device to measure current, we have to change the wires a little bit.
Okay.
And it has to actually go through the multimeter.
Okay.
So the current actually has to flow through it. And so what we're going to do is we have to connect it up in series with it. So I have to actually hook it up as if it's part of the whole
Would
system.
it be better if you laid it on the table for this one?
Yeah, and
we
then
could see it
so I'm going to
from up
go.
above?
I have to change two things on this. I have to change the wire from the red wire to this side that says amps, and then it's beeping at me because it says you have it set to volts, and it doesn't like that because I can short the device out if I don't do it right. So I'm going to set it to amps, and now I'm going to hook this up. And if I hook this up right, the bulb will go on.
We can go this way, and
And
the
then
camera or the.
And so it flows through here, and the light bulb should light up, and it does. So it's at, I don't know, I can show it.
Oh, hold that.
Okay.
So we're gonna try to see it from up above. There we
Okay.
go.
So it's at 0.154,
And that's
or 1.164, and that's amps. So it's about 1.16 amps, depending on how I'm breathing on it. I think it's a little bit of, there you go, there, 0.17 amps, and that's the current.
okay.
So if we talked about how, using that river analogy for the resistance would be how much, how narrow the river is, how many rocks there are in it will stop the flow. Well,
Volts
the
or amps?
amps. This is amps. The current is how much of that flow is happening. How much water is flowing by is how many amps there are. And so we have 2.68 volts and 0.171 amps. And so what is the resistance?
So if this is 2.68 and this is 0.171, then you have to figure out what I is,
Yes.
the amp. So take this number divided by this number.
That's right.
Okay. Do you want me to do that?
Sure.
Okay.
Let's do some math.
Let me grab a calculator. 2.68 divided by 0.171. And what's it supposed to be?
What's the number supposed to be?
Yeah.
I can't tell that from this. I have to set it up to do it. So.
15.
Okay, about 15. So about
0.67. So
15, about 15, 16 ohms.
okay.
Yeah, this thing's not doing that right. Anyway, so that's what you could do. So again, we can have, and so what would happen now if I did something else? If I, instead of doing that, what's going to happen if I take another bulb and I hook it up, but this time instead of like hooking up together, I'll hook them both up at the
So
same
a bulb
place.
hooked up to a bulb, right?
Yes. This way? Yeah. Okay, perfect. Okay. So, and then I'm going to put another bulb in. I'm going to hook this up in what's called parallel and see what that does to my. First of all, I'm going to make sure it turns on. Now I have two bulbs. I have a red and a green hooked up. And let's see if they both light up. It looks like they do.
They did.
They do. And it looks like there's about the same brightness. I'll put that over there together.
So is that how they make strings of lights? They
do.
hook the wires
When you hook them
together?
up like this, I can remove one of these bulbs and that one still lights up. I hook them up, we'll see, hooking up together, they won't. But let's see what this does to the current. Let's see what it does to the current. So,
Okay.
So now I'll hook this into here.
We don't have much time left. Are
Okay,
we going to
just
have
real
enough
fast.
time to show it? Let's see. About 2 minutes.
Yeah, good time. So I'm going to hook this into, so it goes through the multimeter.
Okay.
And where our current was before.
Current is the amp, right?
Is amps, yes.
Okay. It was 0.171 amps
I'm
before.
I'm not getting it. I'm not lighting it up, so I must have something not hooked up very well.
Do you have fun when you put lights up
I do.
around the holidays?
I do.
And then when they don't work, do you fix them?
I try to. It used to be when we were hooked up in series when I was a youngster, and
So series meant that if one went out, it was okay, right?
no, series meant that one went out. It wasn't okay.
Oh.
This is working okay there. I did something wrong with this. So, okay. So let's take a look. Actually, if we take a look at this is in parallel. Let's put them in series real fast. And I'll put them in series real fast.
Okay.
And then that means I hook them one
So
after the other.
parallel lights were okay because if one burnt out, you didn't have to throw the whole thing away.
That's right.
Right.
But if I
okay.
hook them up in series,
Series. One goes out, they all go out.
let's just hook this
What
up.
a bummer.
So this is really dim.
Okay.
Now, if I take one out, though, they
Ah!
both go out. They both go out.
Well, thanks for joining us, guys. Have a good rest of your week.